Warm-up for lesson 7-7. Let's review the exponential graph and the inverse. And the points that I'm using are 0, 1 for my x, 1, 2, and I go ahead and graph it. This is my exponential function. I can reverse the coordinates and I will get my inverse, which is log base 2 of x. Pause and try to do this graph and its inverse. And here are the answers. Lesson 7-7. Evaluate expressions involving the natural base and natural logarithm. Solve exponential equations using natural logarithms. Let's take a look at a new number. It's called e. And it's going to be the base that we're going to be using, and it's going to be the inverse that we're going to be looking at also. Now here is e. Now where does e come from? Well, it comes from this expression as n increases. So I let n be the number 5 here, and when I put it in my calculator, I got this value. Then I wanted n to get bigger, so I used 10 and 10 here, and this is the value I got. Then I did 50 and 50. This is the value I got. 1,000 and 1,000, and this is the value. So you can see it's getting closer and closer to this value. Now this number is about 3, just like pi is around 3. And this is base e, this strange number that we have. We use e instead of writing all these decimals. And we have a brand new way of writing that, and it's natural log of x. Now, I know it should be NL for natural log, but this comes from the French version where they say logarithmic naturel, and so, but we say natural log right here. Okay, so f of x is equal to e to the x is the exponential function, and the natural log of x is the inverse function. So when you take a composite, you're going to get x, and if you take the compacts in the reverse direction, you're going to get x as well. This again is the graph of the exponential function, e, and here's the natural log of x. Now what happens if you want to graph e to the opposite of x? Well, that's 1 over e to the x, or 1 over e to the x power. Remember, 1 over e is like 1/3, so it's going to act like a base. It's between 0 and 1. And then here's its inverse. Let's go ahead and practice changing from an exponential to a logarithmic. So this is our base, and that's what we're going to put here. And this is our exponent, which is what we're going to put here. Now we normally don't write log base c, we just write the natural log of 8 is equal to x. Again, this is our base, so we go to natural log. Our exponent is isolated. Natural log of x is equal to 5. We're going to write natural log because that's our base, and our exponent is going to be isolated, and the 9 belongs here. Natural log, and then we're going to write x, and our exponent is isolated. That's what a natural log is, it's an exponent. Okay, pause, and here's the answer. Pause, and here's the answer. Let's take a look at going the reverse direction, logarithmic equation to an exponential form. Okay, our base is e, here's e, and this is the exponent, and that's what I have here, is approximately x. Our base is e, there's our exponent, x is equal to 10. Our base is e, this is the exponent, 2.1438 is equal to x. E, and this is our exponent, x is equal to 18. Pause and try the problem. Here's the answer. Pause to do the problem, and here's the answer. Let's take a look at simplifying expressions with e and the natural log. So we have these two log expressions, and we're going to use our properties. We're first going to take the 3 and bring it as the exponent, and so that's what we have here. And this is a difference of 2 logs. The difference of 2 logs is the log of the quotient, and then we're going to put this in our calculator, 125, which is 5 to the 3rd, and then you can take this 3 and bring it out, and that is one single logarithm, which is what they're asking us to do. We want to bring this to an exponent. 1/2 to the second power is 1/4. All of these are pluses, so the sum of the logs is the log of the product, and here's our single logarithm. We're going to do this problem here. I've changed 8 to 2 to the third and 4 to 2 to the second, and I'm going to go ahead and I'm going to take 6 and I'm going to bring it up here, and 2, and I'm going to bring it over here. So this is going to be the natural log of 2 to the third to the sixth minus natural log of 2 to the second to the second. Pow, pow, multiply me now. So that's going to be 18 minus the natural log of 2 to the 4. Now I'm going to subtract natural log of 2 to the 18 all over 2 to the 4. And then this is going to be the natural log of 2 to the, I'm going to subtract, that's 14. And then I can bring the 14 down over here to go ahead and make that 14 natural log of 2. Now to do the 3b, I'm going to take all of the numbers that are being multiplied and make them exponents. Natural log of 5 to the second plus the natural log of 2 to the 4 plus the natural log. Can't do anything here. Now these are all sums. The sum of the logs is the log of the product, so I can just put them all together and multiply them. And that's about all you can do. Pause to do the problem, and here's the answer. Pause to do the problem, and here's the answer. Let's take a look at solving for x with a base e equation. So we want to isolate the e, but we first have to undo the subtracting. So we're going to add 5 to both sides. Then we're going to isolate the e expression, divide by 4. We don't really need this step. We can go from this step to here because we can go from an exponential expression to a log. So this is the natural log, and here is my exponent. Remember, has to be isolated. Natural log of 2. Now I want to get x by itself, divide by -2, and then here it is after you use the calculator. Okay, here are the answers. I just really want to emphasize how to do the algebra. So this is 3e to the 4x. I'm going to add 12 to both sides, so that's 27. Now I want to divide both sides by 3 to isolate the e expression, and that's 9. Now I'm going to write it as a natural log. So the natural log, the base is e of 9, and that's when I isolate the exponent for x. So I'm going to solve for x. X is equal to the natural log of 9 over 4, and if you put this in the calculator, you will get this number, 0.5493. Let's go over here, and this is going to be 4e to the opposite of x, and I'm going to subtract 8 on both sides, and that's 9. I'm going to divide both sides by 4. So this is e to the opposite of x is equal to 9/4. And I'm going to write the natural log of 9/4 equals, and then here's my exponent. And now I'm going to get rid of the negative, and this is going to be negative natural log of 9 over 4. And I can go ahead and put in the calculator that way, and this will be approximate -0.8109. Your turn, pause, and here's the answer. Let's take a look at solving an equation that has a natural log in it. So I'm going to divide both sides by 3, and I'm going to get this. And then I'm going to convert from natural log to an exponential, e to the 8, this is the exponent, 4x, solve for x, and then put it in the calculator. Alright, so I'm going to do this problem. I'm going to do 2 natural log of 5x is equal to 6. I'm going to divide both sides by 2, so I have the natural log of 5x is equal to 3. I'm going to convert that to an exponential, e, and here's my exponent, 3 is equal to 5x. Then x will be equal to e to the third divided by 5. And I'll let you go ahead and put that in the calculator. Pause to do the problem. And here's the answer. Here's our last topic on continuously compounded interest. Now this was our amount formula before when we were compounding it for n times, and could stand for quarterly, it could stand for yearly, whatever. But when we do it continuously, that means we're doing it over and over again, then this expression simplifies to principal e to the rt. And r, again, stands for the rate, and t stands for the number of years. So let's take a look at this problem. Suppose you deposited $700 into an account paying 3% compounded continuously. As soon as it says compounded continuously, we use the PERT formula, P-E-R-T. All right, and our P is going to be $700, and our R will be equal to 0.03, and T will be equal to 8. So our amount will be 700 E, and then we're going to have 0.03, and we're going to times it by 8. When you put that in the calculator, this is the answer you're going to get. And you can see that's an amount bigger than 700. Now in this problem, we are being asked to how much would you have to deposit. So we don't know what P is, but we do know our amount that we're going to get after we leave it in the bank is $1,500, and we know that R is 0.03, and the time will be 12. So I'm going to write 1,500, I know the amount, I don't know what P is, E, and then this is going to be 0.03 times 12. So now 12 times 0.03, I think I can simplify that, that's 6.3, so that's 0.36. So I'm going to divide by e to the 0.36, divide by e to the 0.36. I'm going to reduce, and then go ahead and put that in your calculator, and you should get this amount right here, which is how much you have to put in order to get 1,500 out. So this number should be smaller than the 1,500. Pause. Here's the answer. Pause. Here's the answer.